So welcome. What is today about? Just a couple of words on that. Maybe a bit strangely, I will start with telling you what today is not about. Today is not about picking out one winner in terms of energy carrier or fuel and then starting to bash on alternatives. That's not what we like to do. We have to realize, I think, that we have a huge challenge on our hands and we will need many solutions. Maybe not all of them that are out there. So today is also about trying to pinpoint those candidates, and we think methanol is one of them with the best potential. And that will probably be dependent on the application, which fuel might be the best match with a certain application. Today is also not about promoting products. So we hope we are keeping the discussions as objective as possible. We're trying to think long term, where do we need to be headed in terms of energy supply, in terms of marine transportation, for instance. Today is about, on the one hand, us being Lund University, the Department of Energy Sciences in particular, also the Energy Initiative at the Lund Faculty of Engineering on the one hand, and on the other hand the FASTWATER Consortium, which I will be introducing a bit later on. So we want to learn about the big questions. Are we concentrating on the right issues? Do we have all of the issues on our radar? And where do we need to focus communication and dissemination efforts, organizing days like these? Where is the demand? But mostly today is about you. So we hope we have collected an interesting program, that we're touching on many different aspects of defossilizing, of choosing the appropriate energy carrier or fuel to enable that, of the challenges we are facing to introduce these things. So please take the opportunities to interact with us, which brings me to this slide on Menti. So don't forget to open menti.com in a browser page and enter the code you see here at the bottom right. That will lead you onto a page where you will see a question to you, or the opportunity for you to post questions. And this will be done in two different ways. During most of the day, we will have speaker presentations lined up, and then the Menti page will clearly show who you are addressing your question to at that moment. Right after the speaker presentations, we'll just take a few minutes for a short Q&A. So there we ask you to really keep it short and mostly go after clarifications, for instance, on the presentation. So that's just a short Q&A. And then after the end of the morning session, as well as after the afternoon session, we will have some more room for more general Q&A, where we can also question all of the speakers up till that point on issues. So please take advantage of this opportunity, post your questions and post those throughout the presentations. As slides are coming up, you have questions, something isn't very clear, please go ahead and post the questions so that we can start collecting these and then work our way through them during the Q&A. So that brings me to the introduction for today. So I want to take a few minutes just setting the scene and then also introducing the FASTWATER project. So I've mentioned defossilizing. I will explain how a number of sectors are moving. The morning session will be mostly focused on transportation, but hopefully in the afternoon you will see that methanol is on the radar of quite a number of other sectors as well. And the first thing I'd like to do is give you a bit of an image of the challenges that we're up against. And those challenges are huge. If you look at how much fossil fuel we're currently using, we're really addicted to vast quantities of fossil fuels. If you look at oil consumption alone, that's about 100 million barrels of oil per day. And to give you an idea about the size of that challenge, if you take an example from the chemistry sector, chemical sector, the example of methanol, for instance, which is now being produced as a building block for the chemical sector, there we're talking about 3 million barrels per day of production capacity. So almost 2 orders of magnitude difference between the chemical sector and the fuel sector. Another example, lots of talk about hydrogen these days. We're already producing hydrogen in pretty large quantities, but there we're talking about 4.5 million of barrels of oil on an energy equivalent basis. Of course, most of that hydrogen, or almost all of that hydrogen, being produced currently from fossil sources, or even being produced to help out with producing fuels like gasoline and diesel. So clearly this is a huge challenge. How can we actually go away from being reliant on these huge quantities of fossil energy? And how can we get in the end to a future sustainable society? And sustainability, of course, is a very broad topic, so we will limit it today to energy. And in a sense, there's there's comforting data out there. Can we go away from fossil energy? Yes, we can, because there's plenty of renewables out there. If we look at the potential of solar, of wind, of bio, we can clearly cover our needs. The example of solar energy, for instance, that covers about 15,000 times the amount of oil that we're currently using. So the potential is out there, but there's a gigantic challenge to scale that up. And we have another problem with renewables. Maybe there's enough of them out there, but they're intermittent. The sun isn't always shining, the wind isn't always blowing. And on top of that, they're not equally distributed around the globe. So next to having to scale up the availability of renewables, this needs to go hand in hand with scaling up large-scale energy buffers. Depending on where you are around the world, it will probably also be necessary to import energy. Not all continents will be able to be self-sustaining in terms of renewables. And if you look at what you need to be able to store energy on really massive scale, then it appears that the most economic way to do that is in a very compact way of storing energy, and that we know as fuels. So fuels will always have a role to play also in a future sustainable society. Where do those fuels have to come from? Well, they also have to be able to be produced from renewables, of course, to make them sustainable. So on the one hand, you can look at biomass, and then you're processing that, you could say, down into fuels. On the other hand, we are looking currently and also producing fuels from the ground up, starting from green electricity, producing hydrogen, and then building more complex fuels or green molecules from that. So what we are talking about is roughly an energy system that could look like this in the future, where we're relying on renewables, solar, wind. The balance between that will depend, of course, again, on where you are around the globe. Produce green electricity that we supply to the grid directly. That's the most efficient route. So that clearly explains why there's such a strong drive currently for electrification. Wherever that's possible, we should definitely electrify. But first of all, next to that, we also need to be able to buffer this energy. When there's excess renewable energy, we should use that to produce things like, for instance, hydrogen through electrolysis, so that when there's a lack of renewables in the grid, that we can produce energy from the stored buffer. Hydrogen itself is probably not going to cut it though, because of its still low energy density. So there's plans in place and various demo projects, for instance, to work up hydrogen into methane. So we need the hydrogen to buffer renewables to balance the electricity grid. But we will probably have to take it a step further, go to methanation, produce what some people have started calling e-gas, so that we end up with a higher energy density. And also, interestingly, we end up with something for which we, in a lot of countries, basically already have our buffer. We already have existing gas grids in which we can store this. That's still just gases. We know that there's issues with energy densities of gases. So if we really want to be able to store large quantities of energy for a sufficiently long time, then we have to take it one step further still and start building liquid fuels so that we can look at liquid storage. In a lot of continents, there's every year 2 or 3 weeks where there's just not enough wind or solar to cover our needs, even if we interconnect all the electricity grids. So we need to be able to bridge these periods, and they're too long to be able to bridge with the gases I just mentioned. You really need liquid fuels for that. So when the energy density needs are such that you require liquid fuels, we can start looking into methanol synthesis, into Fischer-Tropsch processes. So then the idea is to be able to balance seasons, depending on the continent, to maybe need to import energy. But then also very importantly, if you look at battery electric vehicles, if you look at vehicles operating on gases such as hydrogen and methane, there's also limits to the amount of energy that you can store. So there's quite a large part of the transportation sector that also needs liquid fuels, that really needs these high energy densities. So if we want this to work, of course, and if we want to take advantage of the high energy density that comes with introducing a carbon bond in fuels, such as I've shown here, then carbon capture obviously becomes a necessity for this to work long term. So that's why we've also planned this in the afternoon session to get updated on the status of this. Of course, there's other voices out there questioning this. Should we avoid this? Can we avoid this? Should we be looking at a carbon-free energy carrier such as ammonia? What is the real potential of battery electric, of fuel cells? Is there such a thing as sustainable combustion engines? So there's a whole plethora of alternatives out there currently. So we need a set of good criteria actually to start singling out those that actually make sense. So this is about narrowing the options. So if we now focus to transportation and heavy transportation mostly, we're looking for energy carriers, or you're looking for propulsion units that will work in the long run. And so what does that mean? Obviously, it must mean sustainability. So any resource, any material that goes into building these energy carriers from renewable energy, building the powertrains, that we should be able to use these in a closed cycle. Think circular economy. That in itself is not enough. Even if we can think up of something where we're using everything in a closed cycle. Next to that, think of the vast quantities of oil I just mentioned. We also need these things to be scalable. And that means that we should be looking at resources that are abundantly available. So we should try to avoid using scarce materials. I've already given the example of oil consumption. Another example is, for instance, just the amount of vehicles out there. That's over 1 billion vehicles worldwide. So that's a huge number that we have to find alternatives for. Of course, using abundantly available resources also plays into these things becoming affordable. And affordability goes hand in hand with scalability. Then finally, transportation. I already mentioned this need for energy density, so these things should also be storable. We should be able to pack enough energy in a compact space. So we're looking for high energy density of the energy carrier. We're looking for high power density of the propulsion units. That also makes life simple, and that again links to affordability, to scalability of your alternatives. And we think if you combine these three criteria, that it's clear that there's always going to be a need for renewable fuels, and at least for quite a large range of the transportation needs, there's a need for renewable liquid fuels. That brings me to the topic of today, so methanol. Why is methanol interesting? On the one hand, because it can be produced in different ways. It can be produced from biomass. It's currently mostly produced from fossil fuels. But we have this very attractive option in the long run that we will be able to produce it using renewable energy, where we start from hydrogen being produced from excess renewables, and then we combine it with a carbon source to build our methanol. And why is methanol so interesting, so compelling? Because it's liquid, and basically it's the most simple thing that is a hydrogen carrier that is liquid at atmospheric conditions. And simplicity is desired. We don't want to aim for very complex fuel formulations, because we have to remember that we have to build these fuels, that we start from renewables and we have to synthesize these fuels. So we have to make sure that the production efficiency is high enough. So then we're talking about the well-to-tank part of the total fuel chain. The fact that methanol is liquid enables us to make use of cheap tanks and of a cheap way to distribute this fuel, which also allows an evolution of the infrastructure. And also important, depending on the application that you're targeting, It also allows retrofitting. For instance, shipping, which we will come to later this morning. We know that the average lifetime of vessels is over 20 years, so it will take a long time if we just rely on new builds for this to make an impact. It's very important to also look into the possibilities of retrofitting. Then I've highlighted the production efficiency, the well-to-tank part of it. Equally important is, of course, once you have your energy fuel, your energy carrier, your fuel, that you can make good use of that. And happens to be that methanol, as you'll hear after me, enables very high efficiency and ultra-low emissions. And high efficiency is also desired, because the other part of the chain is the tank-to-wheel or the tank-to-propeller chain, or part of the chain. We have to be able to make sure that the conversion efficiency is also maximized. Methanol currently is gaining quite a bit of traction, evidenced by the number of you signing up for this event. So we were very pleased with that. There we see three things in motion currently. We see on the one hand the power sector, which, as I've mentioned, is looking for ways to be able to buffer energy. So methanol works as a liquid hydrogen carrier, which makes it attractive versus alternatives economically to store and distribute these vast amounts of energy. So the power sector is looking into methanol. Secondly, the chemical sector is looking into methanol, because we mustn't forget that almost 10% of the oil we're getting out of the ground now is actually going to the petrochemical industry to make a huge range of products, from clothes to household things, whatever, a huge range of products. So this is also needed, or we also need an alternative there. And there methanol acts as a building block to make more complex hydrocarbons, for instance, through the methanol to olefins process. And then third, obviously, I've already mentioned it, the transportation sector. There, the fact that methanol is liquid means that you have an acceptable energy density that you can cover quite a number of applications. Which brings us, first of all, to shipping. That started looking into methanol over 10 years ago, when new pollutant emission regulations loomed. So we had the IMO Tier 3 emission legislation coming up, and then people were looking for the economically most feasible way to cut oxides of sulfur emissions and oxides of nitrogen emissions. Methanol offered a possibility to do that, but gradually, the recent years, the shift started to look into greenhouse gases. IMO is planning to, or has put forward the target of cutting greenhouse gas emissions from shipping by 2050 with 50%. So that's a huge challenge. And so now the scope is actually widening and looking at renewable methanol as also a way to cut these greenhouse gas emissions. So there have been several initiatives out there investigating methanol as a fuel for shipping. There's other projects out there currently, such as the Best Energy project in Belgium, looking at how e-fuels link to the evolution in the energy sector. There's the Green Maritime Methanol Consortium in the Netherlands. Germany is looking to convert vessels to methanol operation. And then obviously I'd like to take a few minutes to introduce the FASTWATER project to you now. So FASTWATER, that's short for Fast Track to Clean and Carbon Neutral Waterborne Transport. So that's a Horizon 2020 project, which is looking into methanol as a fuel for shipping. So the project core idea is basically this circular economy idea that I showed you earlier. Can we produce methanol in a sustainable way, in a way that we can actually power our ships on? As mentioned, there's a number of initiatives that have been going on in the past years. There are vessels out there sailing on methanol. But when we sat down to draft the proposal for this project, we started realizing that there's still a number of bottlenecks that we're running against. So what are the challenges that we're trying to tackle with this project? One of the bottlenecks that people informed us about, people that wanted to actually get started on using methanol as a fuel, was just very practically the availability of engines. So there are engines out there, as you also will hear later this morning, large two-stroke engines. That's a commercial product on methanol. But there's a lack of four-stroke methanol engines. so engines that are a bit smaller, that are covering a larger type of applications of vessels. And there's also, as mentioned, a need for retrofitting of marine engines for methanol operation. So that's something we will target, and I'll explain you a bit more concretely how we're going to do that in a minute. In order to get the whole chain working, of course, to think long term, it's also equally important that we set up a demonstration of the full chain going from renewable methanol production to ships actually sailing on it. So that's a topic that we'll pick up throughout the day. Any alternative fuel that you're going to introduce, there's a huge number of challenges to be overcome because this is such a complex chain and so many actors that you need to get moving. So we're talking about renewable methanol production through distribution, through bunkering, through then actually ships sailing on it. And then finally, for the application of shipping, we've observed that there's some initial rules and regulations out there that allow you to run basically on anything different from the classical fuels, but that's currently relying on acceptance on a case-by-case basis, and is currently very much focused on particular fuels such as LNG, which have quite different characteristics from methanol. So we also want to have a look whether we can simplify these rules for the case of methanol to lower the thresholds to make it easier for people to convert vessels to methanol operation. This is a 4-year project that started last June, has 14 partners, which I'll name in an upcoming slide, and has a total project budget of 6.4 million euro, 5 million euro of which is coming from EU funding through the Horizon 2020 program. So how are we going to address that first bullet point? How are we going to make sure that we have engines? Very concretely shown here on the left, we're going to work on making medium speed engines available on methanol in dual fuel operation, so methanol being ignited by a pilot diesel injection. There we will demonstrate 2 megawatt engines, and by the end of the project we plan to have engines commercially available between 1 and 4 megawatt. At the top right, you see a high-speed engine, a 400 kilowatt engine that will end up in one of the other demos that will operate in MD95 mode. So that's a single fuel solution where we're going to compression ignite a mixture mostly consisting out of methanol, but there's some 5% of ignition enhancer in there to ensure the ignition. And then on the bottom right, you see another high-speed engine where we're going to apply a retrofit kit to check whether we can retrofit existing diesel engines to dual fuel operation of methanol. So apart from these engines actually being demonstrated, we're also going to supply by the end of the project retrofit kits or make them commercially available. I've mentioned the demonstration of these engines. That will be done in these demo cases. At the top left, you see a harbor tug that will be converted to use 2 medium speed engines, 2 megawatt each, running dual fuel operation on methanol, and will be sailing in the port of Antwerp in Belgium. At the top right, you see a pilot boat that will be sailing off the east coast of Sweden that will be equipped with this high-speed MD95 engine. At the bottom right, you see a Coast Guard vessel that will be equipped with this retrofitted diesel engine, retrofitted to dual fuel operation with methanol off the coast of Greece. And then finally, at the bottom left, we're also going to work out the design for a river cruise vessel. What is needed to have these river cruise vessels operate on methanol? How is the design going to be impacted? So who are we? That's 14 partners where we've tried to cover the value chain. So we have collected universities and research institutes, we have collected engine manufacturers and equipment suppliers, a fuel supplier and distributor, naval architects and consultancies, shipyards, a classification society, and then fleet owners who simultaneously also act as either port authorities or administrations. This covers part of the value chain, mostly focused on shipping, but any new fuel, of course, there's many more partners that are needed for that. So the way we've tackled that is by installing an advisory board. to give us advice on the best routes for initial exploitation, to help us out with increasing the project exposure, identifying early movers, and also help out, if needed, with the adoption of simplified guidelines. So of course, renewable methanol is a very important part of the puzzle there. So we have a number of renewable methanol producers on board. On the other end of the chain, we have ship owners that have expressed an interest in running some of their ships on methanol. We have authorities to help us out with giving us feedback on the possibilities concerning guidelines. And we have propulsion technology manufacturers, engineering consultancies, R&D institutes, so the technology providers. So how is this going to help us move forward? We hope that the following things will benefit other initiatives looking into methanol too. So first of all, of course, the engines becoming commercially available, which make it feasible to start converting vessels. Same thing for the engine retrofit kit. Very importantly, I think, these real-life demonstrators that we will have out there that will be clocking up a lot of sailing hours and that you will be able to visit to get a hands-on feel for practical applications of methanol as a fuel. And together with running these demonstrators, we will test training material also for crew and onshore personnel. This is still a new thing, so it's important that we install the right type of training. These simplified rules and regulations I've already mentioned, as well as the renewable methanol supply chains to really demonstrate them. And then at the end, of course, we hope that we will be able to propose business plans that we will launch some investment decisions off the back of this project. So please make sure that you follow us. You can hook up to our LinkedIn page for the FASTWATER project. You can follow us on Twitter as well as on our web page. So thanks for listening. This concludes the introduction of the day as well as of the FASTWATER project, and then we'll first check whether we have some questions on this part before we proceed. And for that, I welcome my colleague, Professor Martin Tuneer. Hi, Martin.
Thank you, Sebastian, and thank you for your presentation. So we have a number of questions from the audience here. And the first one is a practical one. Will the material from this day, will that be available for the audience afterwards, presentations and videos and so forth?
Absolutely, yeah. So we will. We have received confirmation from all the speakers that we will definitely be able to share the slide decks, and we're also working actually to be able to share the recordings of the presentations afterwards, and that will be available on the FASTWATER webpage.
Yeah, that's great. So next question. So don't we lose too much efficiency going from hydrogen to methane or methanol?
That's a very valid point. There, I think, again, it's very important to look at the whole chain. So obviously, indeed, it's going to need energy to convert hydrogen to methanol or to methane. Currently, with the numbers out there, but we will get updated numbers about that later on today. It's about 70% efficient, going from for instance, hydrogen to methanol. I think the important thing here is then to compare that to the alternatives. Say that you would want to sail on hydrogen directly, then we have the energy density issue with hydrogen, which means that we either have to compress the hydrogen or we have to liquefy it. Liquefied hydrogen is on the table as one of the options there, but it's important to realize that it also takes 30% of the energy contained within hydrogen to just liquefy it. We have to remember that it takes taking down to 20 Kelvin to minus 253 degrees Celsius before hydrogen becomes liquid. So there's a huge energy penalty associated with that too. And that's not the end of your worries in the case of hydrogen, for instance, because then once you liquefy the hydrogen, you still need to be able to distribute it, to store it. And there's just because you still only end up with a density of styrofoam. Liquid hydrogen has a density of 70 kilograms per cubic meter, so it's still very energy inefficient to carry around this hydrogen. So from the whole perspective, I think it does make sense to look at something that is just very much more convenient to carry around, such as methanol.
Right. There's another question here about CO2 capturing from the atmosphere. Yeah. How about that from an economic feasible context?
That's also a very important, very valid point. So as I showed with the complete energy system layout, if we want to take advantage of the energy represented by a carbon bond, then we have to be able to capture carbon. In order for that to work in the long run, that means capturing carbon from the atmosphere. And so at first sight, that sounds like complete science fiction. Apparently it isn't so. There's quite a number of demonstration projects on that. But I'll actually not completely answer that question, because that's precisely one of the presentations we have lined up in the afternoon to inform us on the state of play there. What about the economics of capturing carbon currently?
Is it time enough for one more question?
Yeah, sure.
Yeah. All right. So the next question is about methanol as a shipping fuel. Is it possible to use diesel tanks? And how much effort is needed for that reuse in that case?
Yeah, I probably also don't want to give too much away, because we will have some presentations later on informing us on vessel conversions. I would briefly say that yes, it is possible. There are some things to take into account, of course, methanol having different properties than diesel. So very practically, that translates to a number of requirements in terms of installing the tanks, on where to provide secondary barriers. Methanol having a lower flash point than diesel, but again, actually, I shouldn't give too much away. We will come back to that later this morning session. Actually,
yeah, we're having a lot of interesting presentations coming up today.
Yeah.
So one final question, maybe before you need to move on. And can you compare and contrast ammonia to methanol as a liquid fuel? Ammonia is, of course, another alternative as an electrofuel to methanol.
Yeah. Also, something that is very alive these days. This question. So you could say, indeed, if we start from sustainable energy and we're producing an energy carrier, ammonia, at least on paper, seems to have sense, because then we don't need carbon to begin with. That would get rid of a number of problems. But then there's two aspects to look at. One is this well-to-tank energy that you need to produce these things. And surprisingly, actually producing ammonia is almost as energy intensive as producing, for instance, e-methane or methanol, because most of the energy cost goes to producing your hydrogen. And then splitting up a nitrogen molecule is also pretty energy intensive. So from a well-to-tank perspective, there's no real preference for going to ammonia over methanol, on the condition, of course, that you have carbon availability, but that will be covered in the afternoon session. And then the second part is, once you've produced your energy carrier, how can you produce your propulsion energy from that? So the tank to propeller or tank to wheel part of that. And there we know that methanol, for instance, or methane, those are working as engine fuels now. They work pretty well. On the other hand, ammonia is a pretty difficult fuel, actually. Mostly you need to throw in some hydrogen to just get this to burn properly. So there's currently actually way more question marks over ammonia than there are with methanol. But of course, we should keep an open mind and collect data so that we take good decisions going forward, that we compare these things in the right sense.
Thank you very much.
Thank you very much for submitting the questions. So you've discovered Menti. That's a good thing. And then I will first give you a brief insight into what the rest of the day actually looks like. So I've showed you this picture of the global energy system, and this we're going to use more or less as a hook for the rest of the day, in the sense that in the morning session, we're mostly going to focus on applications of methanol as an energy carrier. And we're going to focus on shipping in particular, because that's where, at least in Europe, we see the most movement currently. So that means that we're talking mostly about tank to wheel, tank to propeller. So I would also ask you to focus your questions for the first Q&A session at the end of this morning on this. So then we're basically talking about the green part here. Anything from having your energy carrier to then using it. Whereas in the afternoon, we will zoom out a bit, and then we're going to focus mostly on the production side of things. So what about producing methanol from renewables? How energy efficient is that? What's the scaling of that currently? So producing e-methanol or e-fuels in general. So that's well to tank mostly. So then you can focus questions concerning that part to this in the afternoon. So what do we have in store for you for this morning session? So looking into the program, obviously this one is ongoing and wrapping up now. Right after me, we will have a look at findings from concluded methanol projects. So what type of conversion efficiencies have we been able to measure? What type of emissions are we talking about? So the state of the art concerning methanol engines primarily, what's done and what is left to do. After that, we'll zoom out a bit more and see what's happening globally, what's happening worldwide with methanol as an energy carrier. And then we'll look into some early mover experience. I've mentioned these large two-stroke engines out there operating on methanol. So what are the takeaways there from this initial experience of using methanol as a fuel, in this case for shipping? Then we'll have a short break, after which we'll continue with looking into methanol for fuel cells. So what's the status there? What are the remaining challenges? Then we'll look at emission reduction challenges and the role of methanol for the application of shipping. So we'll get the perspective of a ship owner and operator on alternative fuels and how does methanol compare with competing options. We'll get a similar perspective from a shipyard. So what does it mean to build ships that can make use of these new fuels? After which we have time for the Q&A session. So then it's up to you. So make sure that you prepare some good questions to make this as useful as possible.